Hi there, thank you for tuning in. I'm Deputy Lamp Maker Smith, and we are That 70s Lamp Maker. So today, we're going to be making some lamps for you guys, lava lamps to be more precise. But first, always remember, safety is #1 priority. So, the materials list we have here to work with is a 2-liter pitcher of H2O, that's hydrogen and 2 parts oxygen. You can find this in your bathroom. Now, look, I will demonstrate. Clean drinking water. Now, the next thing we have is pure canola oil. Great value, to be more precise. Doesn't have to be great value, but it's great value. And it's sunflower oil, not canola oil. The next thing you're gonna need are your colors. We have my 2 favorite colors, No Taste Red and Teal. This is for our first one, this is for our second one. Our catalyst we have to work with is Alka-Seltzer tablets. And now what a catalyst is it's the thing that sparks the reaction in the first place. Remember, it's gonna fizz, so wear your hats. The next thing you're gonna need are your funnels. We have a big funnel and we have a little funnel. The big funnel is going to be used for our top of the line tier, but still highly affordable plastic bottles. Now what you do is you fasten it on there like so, and then you proceed with the experiment. We shall show you that in a couple minutes. The little funnel is used for our top tier of the line bottles, and as you can see, it's got a lovely light reflecting palette on the bottom of it, wrapped in our nice shiny tape, and it comes with a lovely lamp with its own on and off switch. It's got a magnet on it, and I'd show you how it works, but out here in the outdoor lab, we have stainless steel tables. The reason we have stainless steel tables is because it is highly sanitary, and as I keep saying, safety is #1 priority. Alright, but before we start this, we need to figure out how this works. So a lava lamp works because of 2 things, density and polarity. Density is a measurement of how compact a substance is. Water is more dense than oil, as you will see later, because the water drops to the bottom and they do not mix. Food coloring is also water-based. That's why it goes down, finds its way to the bottom where the water is, and mixes in with it. Now, even though they're 2 very dense, different densities, they will eventually mix, actually. But it's polarity that keeps them from mixing. Water is polar because it has lopsided electrical charges that attract other atoms. Real lava lamps use heat, they use bulbs, and we aren't using that today because in order to make a heat-powered lava lamp, you will need some very expensive, dangerous, and hard to come by materials. So instead, our catalyst will be Alka-Seltzer today. So let's just get right into this experiment. So the first thing you're going to want to do is you're going to want to mix together your colors thoroughly. Now, we'll start with the first one, which is No Taste Red. Hi, Mr. Wasp. So you just pour a little bit into there, not too much, and then
a little more.
You want to pour a little bit more.
For a nice, deep, rich color.
Oh. Oh boy. Sorry for the interruption, folks. 2 things not to do at home. Don't spill, and don't get an outdoor science lab, because nature can be dangerous. And as you know, safety is #1 priority. Okay, so the next thing we're gonna do is we're gonna mix together our teal color. As you can see, we're pouring in the teal. Not too much, but not too little either. You want to have a nice, crisp teal color. And then you mix it up in your handy dandy glass. And that's all there is to it, folks. Now you're going to want to close off the cap and put these aside because we aren't going to be using them anymore. And as you know, a clean workspace is a safe one. Safety is #1 priority. So what we're going to start with, our first bottle, which is going to be the red one. And what we're going to do is we're just going to start this science project right now.
Hold it.
So you want to start with water. You want to have about a quarter water and about 50%. You want to have about a quarter of space left. Now you're just going to want to pour your water into your funnel. There you go. That's enough water. And then next you're going to want to pour your great value sunflower oil. And once again, you want more of that than water. And as you can see, the oil and the water aren't actually mixing. And I should have got a fast pour cap. It looks to be they're mixing, but when it calms down, you'll see that they aren't.
Portal.
Alright, that's about good. We used all of our sunflower oil. So, next you want to take...
Put it down on your table.
Next you want to take your food coloring, all stirred up and looking nice, and you want to just extract a little bit. So now that we've extracted it, I just want you to appreciate how well the oil and the water is separated. You can see there's an actual visible line of where the water ends and the oil begins. So what you want to do is you want to squeeze about 8 to 10 droplets of your food dye into here, and you'll see it passes straight through the oil and goes into the water. 3, 2, 1. There you go, there's 10. So as you can see, it's about to enter the water. We'll give it a little bit of convincing.
No, tap the water. No, you gotta be talking.
So as you can see, stainless steel is very good because we can bleach this when we're done. Now,
It will pass through.
it will pass through eventually, but as we're waiting, we'll talk about how to break up the Alka-Seltzer. Sorry about that, folks. Now, as you can see, it's passed through, but it's not quite red enough. So you can always add more colors. So we're just going to add a little bit more, very, very professionally, I might add. And then if it's not going through, you can give it a little bit of encouragement and just sort of tap it down there like that. Now, there will be some stragglers that are still just chilling there, but they should go down fairly quickly. Now, while we're waiting, we need to take the Alka-Seltzer tablets and just open that up. Now, this has 2, so we'll be saving this one for later. Make sure not to litter. Now you will want to bring your lava lamp over here and break apart the Alka-Seltzer tablets. We just want a couple little pieces here. So, that's good. That's good right there. So now we have three little Alka-Seltzer pieces, and as I've explained earlier, this will be our catalyst. So, when we drop these in, it should form a lava lamp. 3, 2, 1. So, as you see here, the carbon dioxide bubbles are forming and are clinging to the water. And it's bringing it up, and then when it hits the top, the bubble pops, and the the water comes down, we're just gonna add a little bit more color.
Move your hand.
There we go. So, as you can see, this is not our top of the line product. This is a good product, but it's not our top of the line product. So as you can see, these are highly portable. You can put your cap on it, save it for later, take your cap off, and it'll be as good as new. And then you just drop some more tablets in, and the whole reaction starts all over again. So as you can see, we have a functioning lava lamp. We shall put the cap on as soon as the reaction starts. And there you go. So we've made a lava lamp. Now, if you will stick around, we will show you how to make the brightly colored, lit up, extravagant lava lamp. Thank you. Hi there, welcome back. I'm Deputy Creator Smith, and well, thank you for tuning in to That 70s Lamp Maker. So, I know we stated last time that we were using Great Value sunflower oil for both our projects, but we wanted to try something different, you know, spice it up a little bit. So, instead, don't try this at home, by the way. So, instead, we're using heavy-duty chain oil for a chainsaw to see if it has the same density, and to see if the reaction will be any different. So, as usual, we'll start with our H2O, still from your neighborhood bathroom. And you will want to pour about the same measurement as last time. Always be sure to keep your workspace clean. Uh-oh. Always make sure to keep your workspace clean, alright? Because a clean workspace is a safe one. And safety is #1 priority. So, we have our water. Now we're going to be adding the heavy-duty chain oil. Now this is where it starts getting dangerous. I know I said safety. Don't do this at home. We gotta very carefully and slowly pour the... Ooh, that's thick. Alright. Remember, this is an experiment, so I don't even know what'll happen. My scientific prediction, if it will pour out, is... My scientific prediction for this project is that it seems to not have the same density as canola oil. So I feel the difference will be... So, sorry about the cut, guys. We just had to fill it in. As you can tell, this oil is a lot more dense, and you can definitely see a change in color. I predict that the oil is too thick to let the bubbles through. So I'm genuinely curious to see how this works. So we will use our handy dandy scoopity boop, and we shall extract some of the food dye. Last time it was a little weak, so we're just gonna add
Push that all the way down to the water now.
a little bit more. We're gonna push it down to the water to make sure it gets in there.
Nice.
So as you can tell, it's nice and teal. So we already have our Alka-Seltzer catalyst all scratched up. So what we want to start with is our light. Put it on the light. We are in our outdoor workstation, so the light might not be as easy to see, but you should be able to see it. Now we will start with one piece of catalyst and then work our way up to bigger pieces and more of them. So let's start with the one. 1, 2, 3. Oh, it's sort of working. Here, let's try out a bit more. There you go. See, there's definitely some differences. As this one was really fast, this one seems to be a little bit slower in the bubbles moving up. Let's just add all of it and see what happens. make sure to wear safety equipment. I believe. Okay, so as you can tell, there's definitely some small differences between this one and the last one. For some reason, it's flowing up instead of down, and it's overflowing a little bit. It's still working. I mean, I can see the bubbles. It's just a little weird. Anyway.
Let's see if it comes back to its natural state.
Yeah. So, it seems to not be going perfectly back to the regular state, but that is expected. It seems a bit more cloudy than it did, but that is to be expected. I think that was a pretty cool experiment. Once again, you may not want to try that at home, but out here on our handy dandy workbench, that's so easy to clean. It's not that big of an issue. So thank you for tuning in to That 70s Lamp Maker. I am Deputy Creator Smith, and I'll see you guys next time.